All right. Hello, everybody. Hi, everybody. Good morning. How's everybody doing today? Good. So my name is Chris Smith. I work for General Motors. I'm here to talk about outsmarting big data today. So thank you much for joining this session, for picking this session. I know we've got a really busy day. There's a lot of great speakers here. So before I get started, I just wanted to say that I actually don't remember how long I've been attending this event personally as a participant. I feel like I've been attending since 2013, 2014. I missed a year due to COVID and things like that. So I've been attending this for about 10-ish years now. I've given a lot of talks and a lot of presentations on different college campuses throughout my career. I've presented to different forms of executive leadership at the different companies I've worked for and things like that. And this event is actually one of my favorites to attend. There's a really powerful concentration of analytic talent and a really good sense of community with this event today. So I'd like to give a round of applause for all of you for not only attending this event, but for giving me the privilege of having my own session today. So thank you so much and welcome. So as I said, my name is Chris Smith and I work at General Motors. I have a computer science degree with a minor in mathematics. I went on to receive a MBA from Oakland University. I live in Rochester, Michigan with my wife and 3 kids that you see there. We're actually very excited that we have a 4th on the way. So very busy time in my household. Thank you. Yeah, my oldest is 3, and I have 1-year-old twins, and we have another one on the way. So it's about to be a busy year for me. If you see me next year at this event as a participant, I'll probably have much more gray hair and look a little bit more tired than I do today. So for the topic, what we're going to talk about today, outsmarting big data when shiny new tech is not always the answer. And I'm going to be real honest with all of you here. In January of this year, I was working on this presentation, and I ended up scrapping it and rewriting it about 3 times. And I had a period where I was like, what am I doing with this presentation, right? The first version of the presentation was like 3 hours long. It was way too academic. I'd never get through it in a session like this. And by the 3rd iteration, I really came down to, if you take away anything from this session today, it should be a little bit of background on how we get here, where we're going, and most importantly, some tools that you can use within your organization. So at the end of the day, this presentation isn't perfect. There's my disclaimer for everybody. But hopefully there's a few things that kind of motivate you and inspire you, and again, give you value you can take back to your organization. So what we'll do, I'll start out with a brief overview of history, which I think is kind of cool. We'll get into the now. I will actually start to break down how some pieces of AI and machine learning work. I'll talk about what they are and what they are not. And I've got a few tools for you to take away, including some stuff that I have here on the front tables. I've got laptop stickers for everybody, and a few of the slides are a bit wordy and hard to read maybe from here, but I've got papers you can have at the end of the flow chart if you're so interested. So a little bit more background about me. I figured I had to start this talk by talking about the first computer that I ever had. So this is a Zenith Z33D+. It's a PC that I inherited from my dad in the early 90s. He actually gave it to me because he got a laptop at the time that I remember being thicker than my iPhone is tall currently back then. And I did a lot of stuff with this computer. I learned a lot of stuff with this computer as a kid. One of the first things I did is added another hard drive, and I remember adding a 100 megabyte Western Digital hard drive. And at the time I was like, oh, I can do so much. I have so much space. And it's crazy now, right? Does anybody else remember stuff like that, where you're adding like a 100 megabyte hard drive and you're like, I'll never run out of space. And then this presentation today wouldn't even fit like on this hard drive, right? So it's kind of funny when you think about, how we've come. And one of the things I wanted to talk about is, I've been in the IT industry and in the analytics industry for almost 15 years now. And I've supported a lot of different types of applications in the automotive space, right? Everything from quality to systems and components engineering to connected vehicle to before sales and after sales and fleet sales and everything in between. And I've supported a lot of like what you might consider really scary mainframe applications. And I've felt the pain of being the person who has to respond to like P1 tickets and stuff like that. And some of those, there's no GitHub repos or anything for some of those 80s developed mainframe applications, right? Even though a lot of the stuff like COBOL's self-documenting anyways. But when you think about the way some of that stuff was written, I kind of wanted to start there and like pause. And this little image really resonates. 1973, what are you doing with that 4 kilobyte of RAM? And it's like, we're sending people to the moon. Right, and then you fast forward to 2019, it's like, what are you doing with that 16 gigabyte of RAM? And it's like, Excel has a dialog box open somewhere, right? So when you think about where we've come, right, it's important to understand where we've come so we can understand where we're going with some of this stuff. Some of the way those systems were built were actually very clever back in the day. People didn't have much space, people didn't have much resources, so I've gotten to experience in my career a lot of the nuance of some of those systems, and you could tell, back in the 80s, this person was very, very clever who wrote this procedure, who did this thing, right? So there's a certain level of that. So starting with that in a baseline and moving on, fast forwarding to the bloom of new data, and I'm dating myself a bit here. I had friends in high school who had a Palm Pilot in the lower left. I don't know who actually had a Palm Pilot by a show of hands. Okay, decent, maybe 40% of you. That's actually pretty cool. So in my lifetime, I got to see the dot-com boom start and end. I got to see the big data boom start to end. Now we're here hearing about AI and generative AI and all of those topics, right? And one of the trends that I think really set off the big data boom was people taking pictures of things, right? So if you see the digital camera that's over there, if you remember things like LiveJournal, DeadJournal, those were all before things like MySpace and eventually Facebook. Yes, I did have a LiveJournal like long time ago. It's long deleted. But what we saw that led to the big data boom was this huge explosion of things that customers were doing, people were doing, right? Talking online, interacting, taking pictures of things, wanting to engage, wanting to connect in social media. So I did also want to call out that back in 2014, I remember attending this summit as a participant. And at the time, everything was coming up big data, right? So there was an article that came out in 2014 that said 70% of enterprise organizations had either developed or will be developing a big data strategy. So I'm going to say that 2014 is the official birth of big data, and we're here in 2024 talking about AI and machine learning, those concepts. So let's have a 10-year anniversary round of applause for big data, everybody. And in a way, we've outsmarted it, right? Because now, when I walk down this hallway, nobody is here talking about big data, right? Remember, it's all AI, generative AI, all that stuff. So let's begin to break this down. Right, and I'll be really honest. I said in the beginning, I ended up rewriting this presentation about 3 times, and I don't pretend to have all the answers in this space, right? Who here has read an article about AI and felt like, holy crap, this is like overwhelming? Okay, that's much more of the room. So some of the things that you hear in the space, some people we'll talk about AI is the greatest human invention since fire, right? I mean, that's how people are talking about it nowadays, right? And I see some people shaking their heads. I mean, are there any like major AI heads here today who are like, oh yeah, man, this is the greatest invention since fire? Anybody feel that way? Okay, this might be a biased sample because you all saw the topic and attended this session. Right, so you're all here because you must have seen the topic and gone, oh, okay, that's really interesting. So what I'm going to do is I'm going to break this down. I'll talk a little bit about what AI is and what machine learning is. I feel like if I can leave you with anything coming out of the session today, it's a sense of simplicity with some of this, which is tough to find nowadays. And I feel like based on the topic that you saw, that's probably why you're here. So let's get into it. And the first place I'd like to start is value, right? Unless some of you work for a tech company where it's your job to specifically develop analytical tools to sell, right? Your business is the technology. You probably work for a company that you're trying to drive new value in some of these solutions, right? So it's very important to think about value and start there. And it's not always about the technology, it's about what the technology does, right? So one of the techniques that I like to think about that I'm thrilled to share with you today, and I have laptop stickers up front for all of you so you can pick these up as you leave. One of the things that I like to do when starting a project like this is to understand the potential value and make sure that you're protected with your project, right? So what I like to do, and I say this is because everybody in my experience is really, really good at this, is being really negative, right? So who here has a knack for finding a way that like, this won't work, this will break, that'll never get approved? Does anybody think that way? Okay, we've got some people. So what I like to do is that happens to be a strength of mine, by the way, right? For those of you, there's some people in this room who have worked with me before, and they can definitely attest to that. So what I prefer to do is really lean into my strengths. So let's lean really hard into those strengths and just be really negative at the start of a project, right? So what you do is you say things like, we won't achieve any value with this project if we don't X, right? If we don't have a way to associate customer IDs to transactions, if we don't have a way to track acquired customers, if we don't ever get executive support, if we don't ever store data long enough to see if we've made a lift in what we're trying to achieve, right? So make this whole list, be really nasty about it, and then just invert the list, right? So when you're thinking about a project, it's like, okay, well, we would fail if we never got executive support. Well, figure out how to get executive support, right? You don't always, in my experience, you don't always come up with this list that would be on the right unless you do this technique. So one of the fun techniques that hopefully you can take back that helps you in your organization, and again, I've got laptop stickers for giveaways here for you. So what I'd like to do is I'd like to play a little bit of a game, and there's only 4 slides, so thank you for indulging me in advance on this. But so in order to get more audience participation, I think it's gonna be cool, right? What we'll do is we're gonna guess the type of analytics and we're gonna guess the tool. So for those who don't know, descriptive analytics is trends of data and what happened. Diagnostic analytics, just in summary, right, is a bit more KPI, it's a bit more metrics on like what we did to get here. Predictive analytics, of course, right, that shows you likelihoods and probabilities of what could happen. And then prescriptive analytics is a type of analytics where you get into confidence intervals, hypothesis testing, what might happen if we go different scenarios, stuff like that. So if someone would like to go first, I'm looking for volunteers who are brave enough to guess what type of analytics this dashboard is and guess the tech that made this dashboard. Any guesses? And it doesn't have to be in order. Descriptive and Tableau. Okay, so very close, very close. Yes, it is descriptive analytics, as you can see the trends. Power BI. Believe it or not, this is the last gotcha that I've had like this. This is actually Excel. Believe it or not. There's a whole series of, yeah, it's funny, right? I'm at an analytics conference talking about Excel. That's really funny. So for those who are interested, though, there's many YouTube channels. One of my favorite YouTube channels that has topics like this, there's actually a guy who makes videos where he talks and he always has his cat like on his lap or on his desk, and he makes incredible Excel visualizations. You should check them out. But again, it's a tool that most people have, and you can actually do a lot with it, as you can see. We'll move on to the next one. What type of analytics and what tool is this? This tool is a little bit easier to guess, as some of you might imagine. Power BI. Okay, any other guesses on tool? Click. Okay, so it is ClickSense. Yes, this is ClickSense. It is VisLib extensions specifically for the Skansky diagram. And then type of analytics. I guess we're seeing things like KPIs up top. We're seeing things like trends. Anybody guess the type of analytics that this is? Diagnostic. Yes, you're correct. You're also correct on picking up there's a trend in the order of this list. Let's move on to the next type. So who wants to guess what type of analytics this is? Predictive, yes. And then what is the tool? Python. Good guess. KNIME, yes, it is KNIME. This is a decision tree in KNIME. This is an example of what that looks like. And for the last one, should be pretty obvious now. Power BI, yes, this is Power BI. And the type of analytics? Prescriptive analytics, right? You see things like confidence intervals, the hypothesis, the lift, right? You as a user have the ability to say, I'll test this, and this is a forecast of what happens. I'll test this is a forecast of what happens. So the point of this exercise is that a lot of these tools are available, and most of your organizations may already have them, right? Or they're free. Things like KNIME Desktop is free. Things like Excel, most people already have. So there's a lot of value that you could realize early on just with some of the tools that you have. But that's not what we're here to talk about, right? We're here to talk about AI and machine learning. So we'll get into some of that stuff. So at its simplest form, AI is just making a computer act like a human. Like the end, right? There's a lot of presentations you might see today that differ. They might elaborate on that, and that's totally okay. It's a very complex topic. One of the things is that it's been around for quite a long time, right? So John McCarthy, Alan Turing, some of you might know them, pretty famous. There are things that came out in the 50s that you'll see in some of the upcoming slides that we actually use today that are under the umbrella of AI, that when you see some of them, you'll go, wow, that's not a new concept, right? We've always done fraud detection in banking for like a long time now. We've done a lot of those things. Technically, those things are now falling under the umbrella of AI, so they get a much fancier name. Types of AI, right? There's three main types. And these are my terms, by the way. So if you're a real analytics expert, you might disagree with me. It's okay. We can talk after the session, out in the hall, whatever. My three types that I like to focus on are artificial narrow intelligence, artificial general intelligence, and then artificial superintelligence, right? So artificial narrow intelligence is things like Netflix watch recommendations, things like natural language processing, chatbots, things like that. That's where most relevant applications are taking place. And I say most now because with the bloom of generative AI and some of those concepts people have been hearing about, we are getting much fancier. Things like artificial and general intelligence, that's like IBM Watson, ChatGPT, things like that. Artificial and superintelligence, some people may have heard the rumors that, Google is holding some AI cognizant thing captive, somewhere like that. But generally things like artificial superintelligence, in my mind, is things for the movies. I know my kids are Iron Man fans, so if you know Jarvis from Iron Man and stuff like that, that's going to be a bit of ways away. But as you can see from the keynote this morning with Microsoft, it might be getting here sooner than we might think. And then machine learning, right? Here, who here, just by a show of hands, when people say AI, ML, they've been combined historically. So is everybody hearing like AI, ML use cases, like they're combining it? So what I'll attempt to do is just break some of that down and explain to you like what that is and what that isn't. So machine learning in my mind is a subset of AI, right? It's a specific thing that does like spam email detection. It finds anomalies, it can show patterns, things like that. There's types, so most of you here, I'm sure, I don't have to go into details, like supervised machine learning, unsupervised machine learning. There's another subset called deep learning, where we can get into the neural networks and things like that try to imitate human thought. And I'll break this down with another slide. Again, it's found on the paper here, of how to use some of these things. So when should AI be used, right? There's a lot of talk about your business should use AI. AI is the answer. AI will help you. But nobody really tells you when to use it or what some examples are. So here's a few examples. If you're in healthcare, AI, there's applications that can help technicians and doctors identify diseases. If you're in the automotive space like me, same thing can apply for diagnosing stuff with vehicles, right? So you get a diagnostic trouble code in a vehicle, you read some sensor data on a vehicle, it's a similar type of application. In education, of course, helping teachers grade papers, robotics and automation, there's, robotic arm detection, route detection, there's ways to If some of you are familiar with manufacturing 4.0 or industry 4.0 techniques, there's things like that. And then, of course, banking and finance, right? Detecting anomalies in transactions, reducing fraud. All of those types of concepts technically fall under the umbrella of AI, some of which has existed for a long, long time, even before the bloom of big data that we saw back in 2014. And then machine learning, of course, right? So when should machine learning be used? Again, I rewrote this presentation about 3 times, and it was way too long the first couple times. So this is like as most condensed that I can get it to meet my 45-minute time crunch. It's when you have a hard thing to solve that involves a lot of data and variables, right? So it's a fancy form of statistic analytics. It's a capability, right? So if you hear about machine learning, it's a capability. Your capability to do things like regression, clustering, things like that. It gives you predictions so that you can make decisions based on data. And the results are commonly visualized using data tools. So a lot of people here, I won't bring up Excel again, but things like Power BI, Tableau, Click, things like that. So again, I get asked a lot, what is the difference between AI and machine learning, right? Is AI machine learning? Is it a part of it? Is it better than it? Is machine learning better? So to make this as simple as possible, I believe that machine learning is a subset of artificial intelligence, as I explained. Now, the other thing that I wanted to leave you with is a tool, and I have papers here in case this is really hard to read for some of you. So I see some people taking pictures, and that's awesome. If people want to pass out these papers to people, we can pass them down the aisles, because I know it might be a bit of an eye chart to see. But what I'm not sure people at this conference will do today is tell you a more granular level of how to get started on some of the projects, right? So we start off here with, do you want to do something a human could do with the right resources and time? If your answer is no, then you don't need AI. You win. Like, good job, right? So say, okay, we want to do something a human could do with the right resources and time. Do you want to check out, process, and understand things like digital images and videos, right? There's a whole rabbit hole of computer vision techniques that you could check out. Just go to Google or something and Google it. And there's a lot of techniques and tools and things available for you. If you don't want to do that, do you want to compare 2 things and make a decision, right? If so, check out fuzzy logic techniques. I know in my line of work right now, there's a few team members here where we're getting very much so into the thick of that. It's kind of exciting. Do you want to get really good at one thing, right? Are you trying to build something that gets good at something, right? Check out expert system techniques. There's a few examples of what those could be. Do you want to automatically carry out a complex series of physical actions, right? So this is the robotic space. So if so, there's a whole bunch of opportunities for robotics, manufacturing, things like that. Do you want to automatically learn from existing data and algorithms and make a decision? This is where we get into the machine learning techniques that I talked about. Do you want to do something complicated in real time, like drive a car or fly a drone, right? So I know working in the auto industry, autonomous driving is something that we talk about. Things like neural network techniques are handy to explore here, right? And then finally, do you want to understand text and audio from humans and interact with it to make a decision? Again, that falls into the natural language processing techniques that you could explore. I know in my living room, we have an Amazon Echo Dot that my kids all love talking to. So they talk to Alexa and shout to Alexa and ask her to play songs and do things like that. And that all falls into the natural language processing rabbit hole. And if you don't want any of those things, then I'm going to say, hooray, you don't need AI again, right? So AI isn't a magic bullet. It isn't a solution for everything. It's simply another tool in the toolbox. So hopefully this is helpful, again, so that you can take it back in your organization and add some value. And I know I'm talking about value a lot in this presentation. And really, for me, it all comes down to value. My approach is to pick your battles and then pick your tech. I've seen in my career a lot of people seem to pick a technology and then figure out, how do we use Databricks? How do we use Snowflake? How do we use something in AWS? How do we use this other tool? And it's always important, if you want to get the most value that you can for your organization, take a step back and go, okay, we'll do this in Snowflake, hypothetically, or Databricks. But use some of the tools here today to talk about value, to understand where you're going and how you get there. A quote that I made up for this presentation is, if the model had just been 1% more accurate, this project would have been a success. I think nobody's ever said that. Like, I've never heard anybody say that, right? So it's not always about being perfect. It's not always about having the latest and coolest technology just to check some buzzword box. Whenever you're implementing something like this, you have to tie it back to, how do we do the right thing for our company or for our clients? How do we get the most value? And one of the things I challenge you all to do is, sometimes you can gain incredible value by using some of this new technology, but it's not always true to realize value now, right? So in my line of work, it's important to have a long-term vision of where we want to go from like a roadmap perspective, but then we break it down and say, okay, we have a plan of where we're going over the next year and a half or so, but what are things we could do this quarter that's kind of a stepping stone, that's not necessarily a throwaway, that help us be smarter and learn where we're going, things like that. So if you have your eyes set on the prize of implementing some really awesome new technology, definitely do it. But at the same time, don't be afraid to realize value that you see now as well. So for my last slide here, and I have this list on the paper as well, as you can see in the lower left corner, how to really get started with a project like this, right? So whatever technology, whatever tool stack that you have that you're implementing, begin small but with the end in mind is what I just explained, right? So defining the objective and value, gathering requirements, and then most importantly for me in my line of work, since I have a background in data engineering and analytics, data collection and preparation, right? Really understanding your data, understanding the metadata for your data, understanding how to heal it. Some of these tools are trying to get there and get smarter with some of the generative AI techniques, but they're not magic, right? They're not silver bullets, right? So if you are investing a lot of money and saying, we're going to build a whole new platform, we're going to do it, it doesn't get you out of having to understand your own data, right? Just a disclaimer there. And then being able to explore and do a POC, right? This is personally one of my favorite steps. This is the step where you want to fail really fast, right? You want to be able to spin something up, study, either accept the hypothesis or decline the hypothesis. And then, step 5 is where you kind of form your final hypothesis after doing a POC for a bit. And then you begin building. You begin actual development of, whatever platform solution you're working on. And then you have to evaluate the steps along the way and communicate your findings. I've worked on a lot of projects in my career that have been quite successful all the way through to like step 8. And somehow, and the reason why this GIF is here on this slide is I've been in a position where I felt like this project is a great success, right? We're doing everything we set out to do. It's working. And I get feedback from some executive that's like, but what's the update on the investment? Like if there's not a feedback loop to your shareholders or something like that, sometimes it might not matter that the team is doing a great job if you don't communicate that. So make sure for sure to communicate your findings, iterate and refine, right? You're never really done with this type of work, right? I've never seen an analytical project where you say, I'm just gonna deploy it. The model is accurate today. I'm going to walk away and leave the org and go do something totally different. And this is just going to run like that mainframe system from the 80s in perpetuity forever. And by the time I retire, the system will just be working exactly how I deployed it. Probably not going to happen, right? There's always going to be an iterate and refine step, and a deploy step as well. So with that, again, I knew I had to shorten this presentation. I couldn't ramble on for 3 hours. I'm happy to take any questions if anybody has them. Thank you again for attending this session and for indulging me with the topic. And make sure for the laptop stickers, I bought all these for you, so if you want to put them on your laptop, they're up here at the front. Thank you so much for your time. So since we have some time, are there any questions by anybody about what you heard? All right, first one up, I think it's David in the back. Hi. I might need Jeff's help to put the presentation back so I can go. This slide, David. That's a great question. So to summarize the question for people who watch this session later, right? David's question is, this is designed in a typical waterfall, and you're right. It's, to be honest, this is the way that I could get it to fit on the slide without too much headache. But the question that you brought up is a great one, right? In your experience, you said these things typically go in a cycle. So yes, absolutely, they do go in a cycle. And as you can tell, many of these things are related, right? So sometimes you're not only trying to be binary and do one of these things, right? Some of the projects you're trying to do, you might say, I'm trying to carry out a complex set of physical actions and do something in the robotic space, but I need to compare two things and use edit distances and SoundX algorithms to compare things. And sometimes I need to train a neural network for another part of it. So yes, it's not completely binary. Again, I'll admit this presentation isn't perfect and I had to do what I had to do to fit this on the slide, which is why I have the papers for all of you. But yes, a good way to think about this is kind of like a circle, if you visualize it that way. And also know that you could have one project that leverages multiple things in this list. Yeah, so that's a great call out. Thank you for making the slide better. Any other questions? Yes.
Do you have an example of a time, like in your past, where you had to consider the use of machine learning and AI and had maybe a lot of discussions about that that you could share with us and what the outcome of that was?
Yeah. So one recent example I can think of last year in my career, we were implementing something. I won't give away too many details. I do have my boss here in this presentation, so I can't give away too many details. But we were working on implementing a fuzzy logic technique to make a decision on something. So what we were trying to do is we had a incredibly huge data set on one end. We were taking requests. I'll leave it vague on that end. And we were trying to associate the two like in near real time. And so we were iterating around and trying to refine how do we make the fuzzy matching better? How do we get smarter with the logic? How do we take things like names and addresses and various names of different things? How do we like structure them, tokenize them, remove certain words that are common? We started to nerd out a little bit, and we can compare addresses with cosine similarity techniques. We can, and at the end, we kind of step back and we're like, part of our struggle is it's just taking too freaking long for this thing to run. Like, we're never going to be successful. We started doing the math, and there's somebody here in the audience who came to me at the beginning of this year and said, okay, if we implement this the way that you've designed it, it's going to take you, for the first set of these records we need to process, if it takes 67 seconds to do one, you've got like 95 days worth of processing, and it's like, yeah, that's totally unacceptable. Like, we'll be failures, right? If it takes that long. So what we actually found, as it might not be a surprise, we eliminated 100 million rows of data from our data set. And what we found is that by eliminating over 100 million rows of data, our accuracy went down like 1% or something like that. So it goes back to one of the other slides where it's like, if this project was 1% less accurate on a fuzzy matching prediction, like, would we care? I mean, we care a little bit, like in spirit, but it's not going to make or break the whole project, right? So interestingly enough, one of my observations when actually implementing something like that is some people might not think, okay, just cut like 100 million rows out of your data set and then run it again and like wing it. But sometimes you have to take a step back and go, all right, what are other options? We've tried to be as smart as we could be. We've tried to scale compute as much as it can be. You know, you've had the calls with Azure teams and things like that of what can we do? Can we add more resources and that stuff? And sometimes you have to take a step back and think, all right, well, once upon a time I had a Zenith Z D33 Plus with a 100 megabyte hard drive. And back then you had to think a little bit different, right? So even now, as crazy as it sounds, with all the cloud computing and all the capabilities, sometimes it's important to put yourself in that mindset and think, you know, do we need to go back to something like that just to make something perform in the now? But yeah, awesome question. Thank you. Yeah, another question. I'm sorry, what was the question? That's a great question. How do we go about eliminating the 100 million records? Well, what we did is we studied where the data came from, right? So we studied where the data came from and how we acquired the data, and we developed a confidence for each record of the data. So it was broken down into tiers, and then we had confidences of how confident are we in this data, and we kind of bucketed it into 3 main tiers, and we made it, you know, it was like an A, B, C situation. So we said we're going to take all the data that's in A, and we're going to take only the data that's in the B tier where we're more than 80% confident on like 3 of the attributes of where it came from. And that, by taking that sample of data, it eliminated about 100 million records, and that's how we do it. There's a lot of different ways you can do it. It's just the way we came up with. Cool. I think David, yes, again.
A quick comment, a little bit of unsolicited advice, my apologies. You talked about how you reduced 100 billion records, you lost like 1% or 10% something of accuracy. Here's a comment to put that into perspective.
Okay.
From a scientist, I'm not a computer programmer, I'm a scientist, but I work in business. Any scientific difference that is smaller than a business decision does not exist.
Okay.
Doesn't change a business decision. Who cares?
Right.
Is this big or this big or this big?
Let's have a round of applause for that. Right. Right. Thank you. Yes, very, very true. Okay, so I've gotten the warning. Yeah, it looks I'm getting the next warning sign, so I'm almost time. So probably time for like one more question if somebody has a question. Okay. One more. Okay. Yep. So it inverts it, right? So if you take something to the -1, it's the inverse of it, right? So if you look at the gift that I have for all of you for attending this session, it's think negative, but then to the -1, so it inverts it, right? So that's kind of the joke of taking the inverse of thinking negative. Exactly. For the first time, it's paid off in this talk right here. Only took 15 years to realize the value. But with that, again, thank you so much for indulging me with this session today. Thank you for attending. I will be attending the rest of the sessions as a participant myself, and I hope you all have a great rest of your summit. Thank you so much.